Good afternoon to all.
Good afternoon, madam.
Okay. Can you all see my screen?
Yes, madam.
Yes.
Okay. I would like to welcome all the students for the second lecture of database designing and the implementation. First of all, we will discuss some key points from the last week's session. Before that, can you all hear me clearly?
Yes, we can hear.
Yes.
Okay, so first of all, let's discuss about introduction to databases. So before moving to the database concepts and the database design, let's discuss about what is data and what is information. That means what is the difference between this data and the information. So I think you all know what is this data. So when we consider about this data, data is a raw fact. Data are known as raw facts. Or we can say it like unorganized fact. Okay. Then information. When we're talking about this information, we can process this data to produce the information. So this is the relationship between data and the information. Data are raw fact or unorganized fact. Then we are going to process this data to produce information. So the information is the process of data, or it can be called as processing after this information can be produced by processing. So the simple thing, data is raw fact or unorganized fact, and we can process this data to produce the information. Okay, now we are going to discuss an example about this data and the information. Okay, this is a repeat session. Okay, so in this case, you can see as an example, let's take ABC shop. Can you all see my whiteboard?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So you can take as an example, we can take a ABC shop. So this is a textile shop. As an example, let's take t-shirt and skirt are the selling items of this ABC shop. Okay. Then in Monday, let's take Monday. In Monday, the total number of shirts sold by this shop is equal to 2. And the number of skirts sold on Monday is equal to 1. This is 2, this is 1. So when we consider about this value 2 and 1, it is a data. That means we cannot produce any decision, or we cannot draw any decision by using this value, this 2 and 1. It is just a fact. This fact indicates the total number of t-shirts sold on Monday, and this fact indicates the total number of skirts sold on Monday. Likewise, let's take some other days. This is Monday, then Tuesday, Wednesday, Thursday, Friday, Saturday, and the Sunday. Okay, so these are the days. In Tuesday, the total number of sales sold, total number of t-shirts sold on Tuesday is equal to 2. This is 3. This is 1. This is again 2. Likewise, 1, 2, 4, 5. Then This is 1 and this is 1. So that at the end of this week, this is from Monday to Sunday. That means 1 week. So end of the week, we are going to find the total number of sales in particular week. So this is August first week. Let's take this is as a August first week. So now we are going to find the total number of sale in this week. So when we consider about t-shirt, 221141, that means 4, 8, 9, 10, 11. This amount is equal to 3, 5, 10, 10, 11, 12, 13, 14. So at the end of this week, the total number of t-shirts sold is equal to 11, and the total number of skirts sold by this ABC shop is equal to 40. So the total number of sales is equal to 5 into 25. So this is the total number of sales in the first week of August. So by using this one, we can find the profit of that week. By using this 25 amount, we can find the profit, and we can predict the selling amount. That means so number of skirts and the shirts can be sold in next week by using this one. Likewise, we can produce some decision based on this amount. So this amount is taken from by using this individual fact. We process this. The processing part is adding all these values to produce this one. So by using this raw data, we produce information. We use addition as a processing part. So now you can see the data is a raw fact. This is a data. So wait. Okay, wait. So this is a raw fact. At the end of this week, by using this raw fact, we already produce the information. So this is the simple concept behind data and the information. Is it clear?
Yes, yes.
Yes. Yes, ma'am.
You can see this is the definition. Data are the raw fact, and the word raw is used to indicate that the fact have not yet been processed, this raw, and to reveal their meaning. Then the information is produced by processing the data. You can see this is an example. In this example, again ABC company. ABC company tracks all the sales of the company through the invoices. So you can see these are the information about invoices. So this is the invoice number, then this is the invoice date, and this is the sale amount. So these are raw fact. When we consider about invoice number, it's just a fact. So it's a raw fact. When we consider about invoice date, it also a fact. So you can see this is a fact. This is also a fact. So the company has generated this amount of invoice within year 2016. In 2016, they already produced this amount of invoice. That means invoice number, then the invoice date, and the sales amount. In this case, as 1, 2, 3, 4, likewise up to 56. Any amount, okay? Then date, you can include some dates like this. And now sale amount. So let's say sales amount. So this can be 1,200 likewise. So you can see there are 58,260, sorry, 58,286 amount of data in this table. So can you make any decision by looking at this table? Is it possible to make any decision?
No.
No.
it is impossible. So this is a huge data environment. So we need to analyze this, or we need to process this one. So as a processing part, we are going to find the total number of sales per month. By using this one, we are going to find the total number of sales. So let's take January. You can find the records of the January by using the date. Then we can add the amount from this place to up to the 31st January. Likewise, we can take the amount of data, and then the sales amount within particular month. So in January, like this, in January, this is the amount. In February, this is the amount. Likewise, we can produce new information set by using this row fact. Then after that, we can produce a graph. So this is a graph which describes the sales in every month in year 2013. So you can plot the graph. This is from x-axis the month, and the total number of sales from the y-axis. So you can see in January this amount of sales. That means sales amount is equal to 1,55,000. In February, you can see sales amount is equal to 1 lakh. Likewise, you can see you can clearly identify the total sales amount by using this graph. So we can predict, by using this graph, we can predict, some key points. So I think you all can see this graph. So when we consider about January to February, you can see there is a small decrement in the sales amount. Then when you are considering from February to April, you can see the increment. So from April to June, you can see small decrement, and again increment, decrement, then again increment and increment. Likewise, we can predict by using, you can predict some, or you can drive some decision, or you can drive some decision by using this information. So the data are raw fact. Information is produced by using the raw fact. So you can use information to produce some decision. So this is the main concept behind data and information. I think it was clear. Is it?
Yes, clear. Yes, ma'am.
Okay. Then if you have any doubt, you can drop a message to the chat box. Okay. So these are the. So when we consider about useful and so these are some key points about data and the information. You can go through this because this is the revision session, so no need to discuss all these things. I think you were discussed these things in last week also. Okay, then when we consider about timely and useful information, it is need to have a good data set. So if you need to produce a useful and accurate information, it is needed to have a good data set. This data, when we consider about this data, it can, so if you need to produce a good information, it is needed to have a good data. So this is needed to be accurate, and also you need to apply proper technique to process this data set into the information. Likewise, you can see there are so many things about data management. So when we consider about this data management, it is a discipline that focuses on the proper generation and the storage and the retrieval of data. So if you need to produce a good information or a correct or accurate information, it is needed to have a good data set. To maintain a good data set, you need to have some idea about data management. Data management is the discipline that focuses on the proper generation and the storage and the retrieval of data. Okay, I think now it is clear about data and the information. Then let's move into the database. So before moving to the database, so as an example, let's take this is a database. So before moving to this database, I think you all heard about, I think you all have some experience with Excel. Am I correct?
Yes, ma'am.
What is the purpose of this Excel? We can use this Excel spreadsheet to store information. As an example, if you need to store the information about students, you can use Excel spreadsheet to store the information. You can take the student name, then the ID, then the address. Likewise, you can store the information by using Excel spreadsheet. When we consider about database, it is just like this Excel spreadsheet. That means it is also a storage media. We use this database to store a huge amount of data with, we use this database to store the huge amount of data with organized manner. That means well organized manner. So in this case, we use this data. This is also a storage media, and we can use this database to store the huge amount of data with well organized manner. So this is a data storage media. Let's take this as a data storage media. Okay. So, but there is a problem. In this database, we can only store the data about related scenarios. So this is the problem. So in database, we can only save or store the data about related scenario. So simply database is a collection of related data. So finally, the database is collection of related data. So I think now you have some doubt about this related data. Okay, I'm going to explain it now. You can see this is your OUSA database. This is your OUSA database. We use this OUSA database to keep the information about student. And this database contains the information about staff, OUSL staff, OUSL student. Then about OUSL courses and OUSL, grades. Okay, so these are the things that contain in OUSA database. Okay, so this is related to the OUSA, that means Open University. Then, is it possible to contain any information about students in Colombo University? Is it possible to contain any data, that means any information about Colombo University students in this database? Is it possible? This is
No, ma'am.
no, this is belong to OUSL. It's only contain data about OUSL. So this is the related scenario. So in this case, database always keep the related data for a particular scenario. So the database is a collection of related data. So when we consider about OUSL database, it's only contain the data about Open University. When we consider about Columbia University database, it only contain the information or data about Columbia University. Okay, I think now it was clear. Is it clear?
Yes.
Okay.
Yes,
Okay.
ma'am.
Then let's move into slide again. The database is a collection of related data. We already know it. Then as an example, let's consider the names, employee numbers, and the address of the people you may know. Then you may have recorded of these data in an index address book. So as an example, let's take the index address book as example. Let's take this address book. In address book, you're going to write the name, then the telephone numbers and the address. This is also a simple database because this only in this case, it only consider about the telephone numbers and the address of a particular person. So it's used to store some information about persons. So this is also a small and one kind of database. Okay. Then when we consider about this database, you can see database can be any size and varying complexity. Now you can see in this case only 3 data and this is a small database. But when we consider about OUSL database, it is more complex than this one. It is needed to have many information about different fields, about staff and the students as well as courses and the grades and the marks. Likewise, this is bit complex than this database. Now you can see the database can be vary with the size and also vary with the complexity. Okay, there is another example. This is the address book and this is the card catalog for your large library. So in this case, it can be 100 or 200 records, but in this case, you can see it has 1,000 or more than that amount of records. So you can see this database can be vary with the size and also a complexity. In this case, it is bit complex because this database contains different information about different fields. So this is complex when consider about this one and this library catalog. Okay. Okay. So when we consider about this database, we can maintain database manually as well as computerized. Okay. So there are two examples. These two examples. That means this one. When we consider about phone book or a address book and this one card catalog, these two are example for manually database. Okay, then let's discuss about so when we consider about OUSL one, is it manual or computerized?
Computerized.
It's a computerized database. So the book is a manual database. When we consider about OUSL one, it is a computerized database. I think now you can differentiate this manually and computerized one. As example, let's take the inventory control system in a supermarket. Let's take a database in keys. Is it manual one or computerized one?
Manual one.
Supermarket, that means key supermarket. Is it manual?
Computerized.
Computerized one. But let's take a small shop retail shop like yeah, small shop අපි බලමු දැන් ඔයාලගේ ගෙවල් වල තියෙන ගෙවල් ගාව තියෙන චූටි කඩ වගේ දෙයක් කඩයක් ගමුකෝ ඒ කඩේ තියෙන database එක ඒක manual එකක්ද computerized එකක්ද ඒක manual මොකද එයාලා computer එකේ ඔය information store කරගෙන sort කරන්න යන්න නැහැ so it's a manual one but when we consider about the database in supermarket like Keys then the Cargill they maintain computerized database. Okay, I think now you can differentiate these two. Then let's discuss about data and the metadata. Okay, so for efficient data management we need to use of the computer database. So it's definitely true when we consider about manual one, it's a huge paperwork. So sometimes it takes a lot of time to calculate some sales. That means it takes some time to calculate sales profit of the company. So when we consider about the computer-based database, so it is very efficient when comparing to manual database. So this computer database shared integrated computer structure that keep the collection of data and the metadata. So when we consider about this computerized database, this database is consists with data as well as metadata. So data, we already discussed about data. Data is the raw facts which are interested to the end user. But when we consider about metadata, it is known as data about data. Okay, so what is this database? In this case, it provides the description of data characteristics and the set of relationships that link the data found within the database. As an example, I think, yeah, as an example, let's take student. I'm going to take one example from your class, Hashini. Okay, so let's take this Hashini. So this is a profile or a data. So when we consider about Hashini, this Hashini is 25. As example, let's take she is 25 years old and she is from Matara, and this is her birthday. Likewise, these are some information about Hasini. So we can use name, then the address and the birthday to identify this Hashini. So these are the characteristics of the Hashini. Okay, so metadata is like this. This is the metadata. So Hashini is a fact or data. Hashini is a student in this class. This is database class. So Hashini is a student of database class. So she has some characteristics: name, age, then the birthday, and so on. So this is known as the characteristics of the Hashini, and these are the metadata about Hashini. Data is Hashini, so a student of a class. When we consider about our class, Hashini is a data, and her characteristics of the Hashini is known as metadata. So these are the examples for the characteristics.
Excuse me, madam, that metadata also stored as a separate database or within that database?
Within that database. I think you can get clear idea about this metadata in upcoming lectures when you are creating database and when you are going to store the information about the store the information in the database. At that time you can get clear idea about this one. Okay.
Okay.
Okay. Okay, then let's move into the database management system. Now we already discussed about data and the information. Then we already discussed about the manual database as well as computerized database. Then we are going to talk. Then These are the components available in the database, data and the metadata. Now we are going to discuss about database management system. That means DBMS. This is the shortened form of this database management system. So when we consider about this one, this database management system is, when we consider about database management system, it's a collection of programs that enables users to create and maintain a database. So this is a database management system. This is a system which is used to that means this enables user to create and maintain a database. So database management system is the software. As example, let's take a program. So this is a program which enables user to create and maintain a database. So you can see in this database management system, you can see some software system that facilitate the process of defining, constructing, and manipulating database for various applications. So defining database. So before creating a database, you need to define the database. So in this case, you need to specify what are the data types and what is the structure, what are the constraints of the data to be stored in a particular database. As an example, let's take this database. I'm going to create a database for library. So it is needed, before creating this one, it is needed to define a database. In this case, I need to identify what are the data types. What is the structure of this database? So as an example, what are the tables in this database? What are the information that we are going to store in this database? Likewise, we can, first of all, we need to define the database. After that, we are going to create in a database. Okay. The process of sorting data on the some storage media. Constructing means this is just like a designing, and we design what we are going to define within this database. In this stage, we are going to create the database by using some storage media. After that, you can manipulate the database. That means we can use any query, or we can use any query to insert data, then retrieve data, and you can use different kind of query to do some calculation on data, and finally we can generate some reports about the data. Likewise, there are so many things about this manipulating the database. So these are the main three steps we are going to talk. We are going to talk about these three things in upcoming lectures, so no need to worry about this. So the database management system is a program that enables user to create and maintain database. To create and maintain database, these three steps are needed. To create and maintain, it is needed to define a database and also needed to construct a database, and you can perform some manipulation on that database. So this is mainly about database management system. Okay, then let's move into database system. This is about management, how you can manage your database. Okay, defining, constructing, and manipulating. These are the main three steps that you can follow to manage your database. Then let's discuss about database system. We already discussed about database. What is database? Then we discussed about database management system, how you can manage this database, what are the main things or main process main process that facilitate in this DBMS. The first one is defining, then the constructing, then the last one is manipulating. Now we are going to talk about database system. When we consider about this database system, database system, I'm going to Write it as DB, database. Database system is equal to database plus database management system. Okay, අපි දැන් ඉගෙන ගත්ත database එකක් කියන්නේ මොකක්ද කියලා. හරිද? ඊට පස්සේ අපි ඉගෙන ගත්ත database management system එකක්. database එක කියන්නේ අපි create කරන්න යන මොකක් හරි database එකක්. database management system එකක් කියන්නේ අපි කොහොමද මේ database එක management කරන්නේ ඊට අදාළ software. දැන් database system එකක් කියන්නේ මම මේ දෙකේ එකතුවක්. කියන්නේ database එකටයි කොහොමද ඒව manage කරන්නේ මොනවාද ඒවට ඕන softwares කියන එකේ එකතුවට තමයි අපි database system එකක් කියලා simply කියන්නේ. Okay, so the database system is a combination of database as well as combination of database and the database management system. In this case, in database, these are the information we are going to. This keep the information about. This keeps the information that we are going to keep in this database, and this describe the how you can. This is the software which enables user to create and maintain this database. Okay, so these two, the combination of these two is known as database system. Okay, then about database design. Database designing is a design of the database structure will be used to store and manage data rather than designing of DBMS software. So this is the designing means you can design the structure of this database. Again, I'm coming to my previous example, this one, OUSL database. In this designing phase, we are going to identify what are the tables in this database. And we design in this table. So this step is known as database designing. In this case, you can identify the database structure and as well as you can identify the how you can store and manage the data rather than design the DBMS software. Okay. There, you can see this is the DBMS. Okay. That means database management system. In this case, you can see this is a database. This is the database management system. I already discussed. This DBMS is used to create and manage, maintain, use. This enables user to create and maintain this database. So when we consider about this one, these are the end users. So when we consider about this end user, you can request data from the database. At that time, this DBMS system convert this small request into a complex request and it retrieves some data from this database and provide it to the end user. This is the main mechanism like this. This is the end user E1. This is DBMS. This is the database. So I'm going to find the number of students in my class from this DBMS. This is OUSL DBMS. So I request this from this DBMS, that means database management system. After that, this system convert my request into complex query and this system retrieve the data from the database and retrieved data. Set of retrieved data is provided for the end user. This is the main mechanism behind DBMS and the database. Is it clear? Yeah, DBMS translates user request into complex code required to fulfill those requests. So this function is done by DBMS. හැබැයි දැන් අපිට මේ ෆන්ක්ෂන් එක මෙයක් කරාට කියන කම්ප්ලෙක්ස් කෝඩ් එකකට මේව ගන්න හැබැයි අපිට ඒක තේරෙන්නේ නැහැ මොකද අපිට පේන්නේ යූසර් ඉන්ටර්ෆේස් එක විතරයි. As an example, let's take sales girl in Kagis. As an example, let's take a sales girl in a Kage. So you can see she can see the interface. She requests something from the system. DBMS provide the response. So she haven't any idea about what the internal process. But when she type in the amount of, as example, let's take she is going to find the amount of price of milk powder packet. So she just insert the code of the milk powder packet. Then system provide the price. But is she have any idea about internal process? නෑ. සේල් ගර්ල් කෙනෙක් ඉන්නවා. එයා කරන්නේ කිරිපිටි පැකට් එක ප්‍රයිස් එක හොයනවා. එයා කරන්නේ ඊට අදාළ කිරිපිටි පැකට් එක අදාළ කෝඩ් එක ටයිප් කරාට පස්සේ DBMS එක ඒකට අදාළ DBMS that means database management system එක ඒකට අදාළ value එක price එක හොයලා දෙනවා. හැබැයි ගර්ල්ට ID එකක් තියනවද? මොකක්ද ඇතුලේ වෙන්නේ? කොහොමද ඒක වෙන්නේ? කොහොමද database එක create වෙලා තියෙන්නේ? එහෙම ID එකක් තියනවද? නැහැ. end user ට එහෙම idea එකක් ඕනේ නැහැ. එයාට තියෙන අපිට අවශ්‍ය දේ system එකෙන් ගන්න. database processing එකයි කියන්නේ කොහොමද ඒක maintain ඒවා ඔක්කොම බලාගන්නේ මේ DBMS කියන්නේ database management system එක. okay. Okay, then let's discuss about redundant data. So why the database design is important? A well-organized database facilitates the data management and become a valuable information generator. A poorly designed database is likely to become a breeding ground for redundant data. So this is also very important, redundant data. So when we consider about redundant data, duplicate data are known as redundant data. As an example, I think no need to put your student number and the registration numbers into chat. Okay. Then when we consider about this redundant data as example, again I'm taking an example. This is let's take like this. Yeah. Let's take customer. Yeah, let's take customer file and another file as sales file. That means sales agent file. Again, yeah, let's check this one. I think it is clear. Data redundancy exists when the customer telephone number is stored in a file, a sales agent file, and the invoice file. If the customer telephone number changes, the correction might not to be made in all locations where it occurs. As an example, let's take this the customer file. In this customer file, let's take some attributes, that means characteristics, as a customer ID, then the customer name, then the customer address, and the customer telephone number. So this is the telephone number. Again, let's take the sales file. In this file also it is needed to have a customer telephone number in this file also. Then when we consider about invoice file, again it need to have a telephone number field. So you can see there are 3 files in the same scenario, but this value is in 3 table or a 3 files. So you can see this value is duplicated. So this is known as redundant data. So if you are going to add the data into these 3 table, you need to add the telephone number into this table and also this table and this table, but these 3 tables or files are related. So you can see same data in 3 places. So this is known as duplication. So the unnecessary duplication are known as redundant data. So the redundant data can produce the incorrect data entries will not, and also it will not know which value is correct one, and report might yield different result. As an example, the customer Sunil. Let's take in this file. Let's take a customer Sunil. Sunil from Madara, age is equal to 56. His telephone number is this one. And he's again in this file, the sales, yeah, sales agent file. Agent is Kamal. Under the Kamal, he's, let's take the NIC of this person as 93. Then this is 93. Then you can see telephone number. This is also 71 number. This is also 71. Again, this is in this table also this record available. Sorry, 71. So after few times, Sunil is going to change his number. So he changed his number as 78, but the data entry person only changed the update in this file. He or she forgot to update in these two files. So this data become incorrect data. These two data become incorrect data. So this is a huge disadvantage for the database system. So this is described in this one. Can produce the incorrect data entries. So you can see this is the scenario that produce incorrect data. Okay, is it clear about redundant data?
Yes.
If you have any doubt, you can raise your question. So this is about session number 1. I think no questions. Then let's move into history of database. So before this database become popular among people, people mostly use file and file system to store their information and the data. So you can see as an example, let's take some information about a student. Yeah. Before this database, madam, could you please explain again what are the related data? Okay. So when we consider about related data, you can see. When we consider about related data, when we consider about OUSL database, this database contain information about OUSL student and OUSL staff and also OUSL post, that means post offered by OUSL, and also students marks and grade. Is it possible to contain or maintain information about Colombo University students in this database?
No.
No. So this is another case. So all these data are related to OUSA, not to Colombo University. So it is, all these are related to OUSA, that means Open University. So this database only contain information about OUSA. So these are known as related data. So these are known as related data. Is it clear, Fatima? I think Fatima. Yeah, wait. Fatima, is it, yeah. Rashmi, is it clear? Okay. Then about file system. So before database concept becomes popular among the society and the people, they used file and the file system to store the information. As an example, let's take grade 6 class in Anand College. Grade 6A class in Anand College. So teacher going to store the information about students. So you can see student ID, then student index number, then student name, student address, and parent telephone numbers. Likewise, teacher going to store the information about grade 6A students. There are only 40 students in this class, so it is needed to have 40. So it is needed to keep 40 records about students. You can see 40 students in the class, so it is needed to keep 40 records in this file. Is it possible to keep 40 records?
No.
Yeah, this is not 40 කියන්නේ සාමාන්‍ය පොඩියක් ගයක්. අපිට 40ක් අතෙන් තියාගෙන ඉන්න පුළුවන් එක අපිට handle කරන්න පුළුවන්. හරිද? So you can handle 40 records. This is only 40 record. It's take only 2 or 3 pages from a book. Okay? But when we consider about a complex case like this, if you need to store the transaction in car keys within 1 month, is it possible to store these records in a paperwork?
No.
In one day, it's more than not 100. Sometimes it can be 1,000. So 30 days, it's all together 30,000. Is it possible to store these things in a file system? That means manual file system. Is it possible?
No.
No. So this manual file system is okay for relatively small data collection with few requirements, but when we consider about complex requirement and the complex data set, it is unable to handle the file system. Okay, so this is the file. Just keep it in mind. When we consider about this manual file system, you can see these are the file. This is example. These are some folders. You can see data or some papers available in these file folders. So this is known as file system. This is a file. The collection of files are known as file system. These are, yeah, you can take it as a file folders. This collection of this file folder is known as file system. As an example, in this case, let's take an example in doctor's office. You can see a patient data that means doctor's office needed to maintain data about their patient. So it is needed to have one file for one patient. As an example, let's take, this is the doctor's office. There are 350 patients for his clinic. So it is needed to maintain 300, let's take 100 files for each patient. When we consider about one file, this may include some medical history of a particular person. So this is the manual system. Okay. Now you can say this is the manual file system. But when we consider about this record, so it is very difficult to handle huge amount of data with this manual system. As a solution for that, with the complexity and the greater, that means with the complexity, it is invented that the computerized file system. this is a manual file system. That means this files is in paperwork like this, files and folders. With the complexity and higher requirement, this is become difficult to handle the files. So as a result of that, computerized file system was invented. So yeah, this is about computerized file system was invented. So to handle this one, it is needed to have a specialist at the beginning of this computerized file system. It has a specialist as data processing specialist to handle this file. So these are the responsible of this data processing specialist. No need to go through it. Then you can see this is the file. This is just like a spreadsheet. I think you have some Excel, you have some experience with Excel spreadsheet. You can see this is just like a Excel spreadsheet. You can use this Excel spreadsheet to store the information. This is just like a Excel spreadsheet. So this is so initial stage, this computerized file also similar to manual file. But with the time, it is improved. Before that, let's discuss about some component in the file system. Is it clear? At the beginning of the, that means at the beginning it was a manual file system, and after with the complex requirement and with the huge amount of data, computerized file system invented. So this is the main, these are some main component or a main vocabulary available with this computerized file system. So when we consider about computerized file system, that means computer files, you can see the basic file vocabulary summary is in this table. The first one is data. So I think you all know about data. So data is a raw fact that have a little meaning or useless, unless they have been organized in some logical manner. As an example, let's take a small piece of data. It can be recognized by a computer and it is known as a data. As an example, we can take a file, the underscore, then the special character as a data. Two 1921755. Do you have any question? Okay. Then when we consider about this computerized file system, this is the basic component data. This is a raw fact and this have a little meaning. So when we consider about a small piece of data that can be organized by a computer is a single character. So the smallest piece of data that can be recognized by a computer is a single character. This can be a or 1, 2, 3, any number or any character. So then about field. So when we consider about field, a character or group of character that has a specific meaning is known as a field. Data is a single character. When we in this is in computer file. So in computer file, data is a single character. When we consider about a field, it is a group of character. As an example, let's take a telephone number. You can see telephone number is consist with 10 numbers. So this is known as a field, but when we consider about one character, it is known as data. Then about records. So when we consider about records, it's a logical connected set of one or more fields that describe a person, place, or a thing. Okay, this is just like our previous example. As an example, let's take the student. So this is about student. Student has a name, then age, then address, and so on. So you can see, let's take Shashi again. Shashi, I think Shashi, age is 25. Then the address is Matara. So this is known as a record. So value for these characteristics. So when we consider about a student, you can identify the students by characteristics. As example, in this case, 151 students. Commonly, we call them as students. So we can identify each and every student by using a characteristic. So Shashi is one record of this file. Okay. So as an example, let's take 150 students. That means students in our class as a file. So all the information about this 151 is available in this file. And you can see there are some field as student name, then the S number and age and the that means address in this file. And Shashi is one student in our class, so she is a record of this file. Is it clear?
Yes.
What about others?
Yes,
ma'am.
madam.
If you have any doubt, you can raise the question, okay? Otherwise, you need to do it again. This is a revision session now, so if you have any doubt, you can raise your question, okay? Now, we are going to identify these things by using this table, okay? This is just like a table, but this is not a table. Now we are in filing system. This is a file. In this file, we already discussed about data, then field. Field is the characteristics of a, that means character or a group of character that has a specific mean. Then record is a field which describes the person or a place or a thing. Then file is a collection of related records. So the students of our class is a file. Shashi is a one record. Name, age, birthday, address are the fields of this file. And when we consider about one value as a Shashi, S is a data. One character is a data. So, okay. Can you identify the fields of this file? How many fields in this file?
8.
1, 2, 3. Okay. Then what are the records in this file? Tell me one or
3 records.
3 records. What are those records?
Alita D. Silva, Malika Pereira, and Ranjan Raisa.
Yeah, these are the records. I think now you can identify what are the attributes or fields and what are the records. Okay, so the total number of records in this file is equal to 3. Then the customer file, this I think is this is this one customer file, this one. How many? Wait. Yeah, in this file, it is used to store the customer information. These are the information. So what is this file? Can you give a proper name for this file?
Customer.
Yeah, customer file. Then how many fields available in this file? Eight.
I feel.
8.
How many records?
10.
10 records. Okay.
10.
Okay. I think now you have some idea about files. These are the things we already discussed. These are the use of computer files. You can save your time and the effort. Yes. So when you are considering about files in paper, that means paperwork. As an example, in this case, you can see 1, 2, 3, 4. In manual file system, we can use one page for this record, one page for this one, likewise 10 page. So if you need to find Mahinda Costa, you need to find it in 1, 2, 3, 4, 5, 6, 7 pages. තේරුණාද? අපි හිතමු පොතක ෆයිල් එකකට මේ ටික දාලා තියෙනවා කියන්නේ ඒක කොලයක් එක්කිනාට වෙන් කරලා තියෙනවා කියන්නේ. එතකොට අපිට මේ මහින්ද කොස්තා කියන එක්කිනා හොයන්න කොල 8ක් 6ක් 7ක් විතර පෙන්නනවා. හැබැයි මේ වගේ සමරයිසේෂන් ෆයිල් එකකට ගත්තම අපිට ඉච්චර වෙලාවක් යනවාද අවශ්‍ය රෙකෝඩ් එක හොයාගන්න? අපිට ඉච්චර වෙලාවක් යන්නේ නැහැ. හරිද? So this computerized file save time as well as effort, and reports will be impressive, and ability to perform the complex data search will yield the information needed to make sound decisions. So this is also another file, agent file. You can see there are three files. So in sales department, according to this example, in this example, agent files are used to write the checks, keep the tracks of the tax paid, and summarize insurance coverage and so on. And the sales department again create a file name as sales to keep the track of daily sales effort. So the number of file increase, a small file system like this figures occur. So you can see this is sales department, this is personnel department. In personnel department, there is a file known as agent file, and in sales department, there are two files as a customer file and the sales files. Likewise, we can create the files by using computers. Okay. Okay, no need to repeat this again. Then about file system data management. So you can see the features lose file system favor on its users and made them to think over new approach of data management. Then with the this one, then this one, file system data management. So new features lose the file system favor, and it user made them to think over new approach. So like this, it can be create many files regarding same case. So they motivated to find new approach to store their information or the way to manage their information. So this is about one drawback of this file system. File system security is less. When we consider about the security of file system, it is less. To protect the file, we can use the password method to look parts of the file in etc. So if you need to protect your file, you can use any password or any other protecting method to protect your files. So since the security is less, pooling or arranging data together become difficult, and also the data ownership has occurred and same data in different locations were found. Against the same question, you can see in this file, it has some information about customer. In this also, it has some information about customer. So the same data with in different place. So it is unable to pool, and not unable, difficult to pool and arrange the data together. So, and also the data ownership has occurred, and the same data in different location, then it is very hard to update the same data in different locations. So these three, when we consider about customer age, not customer age, customer telephone numbers, all these three files consist with this field. So if I corrected this one, it is needed to update this and this also. So it becomes difficult. Because of that, these are some drawbacks of the file system, that means file system data management. After, as a solution of these drawbacks, it is invented database concept. It's at first manual file system, then computerized file system, then database. Before moving to database, let's discuss about structural and data dependencies in a file system. So these are the drawbacks of the file system. Now we are going to discuss about structural dependence and the data dependence. As an example, so if we change the data in one file, that means if we change the fields in one file. So as an example, let's take, I'm going to delete customer telephone number from the customer file. So it is needed to delete in other file also. At that time, this structural dependence occur. That means if we do a modification, that means add or delete a field to a structure of a file, it is required to modification of all the program used in that file. So as an example, let's take this file is used by this program P1, P2 and P3. If I delete this one, it is needed to modify in these three. So this is known as structural dependence. That means this P1 is depend on this one. This is also depend on this one. This is also depend on this one. That is known as structural dependence. So the data dependence means if we change data in one file, it is required to change all the that means that data in all the programs. As an example, let's take this one. In this case, customer file, I'm going to change Mala name as, that means Mala's telephone number as 725. So it is needed to, this file is linked with this sales file. So in Mala, records of the Mala are available in this file also. If I change this one, it is needed to modify the data in this also. At that time, we can have some data that means data dependence. Even if we change the data in one file, it is required to change all the program that access the file. Such modifications are required because the file system exhibits data dependence. That is, access to the file depend on its data characteristics. So this is small case structural dependence and the data dependence. අපි දැන් කියනෝනේ files එක්කෙනා එක්කෙනාට සම්බන්ධයි කියලා අපි මේක file එකක් තව program එකක් use කරනවා කියලා. එතකොට අපි මේ file එකේ තියෙන මොකක් හරි attribute එකක් කියන්නේ field එකක් delete කරොත් ඒක මේ program එකට බලපානවා. මෙයා මෙතන මේ attribute එක or field එක delete කරනවා නම් අපි මේ file එකෙත් එයාව delete කරන්න ඕනේ. එහෙම delete කරන්න ඕනේ වෙන්නේ මෙන්න මේ structural dependence එක නිසා. data dependence කියන්නේ අපිට මේ ෆයිල් එකේ මොකක් හරි data එකක් තියෙනවා ටෙලිෆෝන් නම්බර් එක 0725 කියලා අපි මෙන්න මේ data එක වෙනස් කරනවා 0768 කියලා. එහෙම වුණොත් අපිට මේකෙත් ඒක delete කරන්න වෙනවා. එහෙම delete කරේ නැත්නම් files දෙකම same කෙනාට අදාළ wrong information තියෙන්න පුළුවන්. මෙහෙම කරන්න වෙන්නේ අපිට මේ data depends වෙන නිසා. Is it clear?
Yes.
Yeah, if you have any doubt, you can ask them now. I will give you 5 minutes. Then let's discuss. I think no questions. Then let's discuss about data redundancy in a file system. I already discussed about data redundant. Data redundancy means duplication of data. So what is this data redundancy? Data redundancy is same data stored in many different locations. That means duplicated data. So this duplicated data or data redundancy occurs two issues. The first one is data inconsistency. Second one is data anomalies. So these two issues are occurred due to this data redundancy. Data redundancy means simply data redundancy means data duplication. So due to this data duplication, these two issues are occurred or raised. The first one is data inconsistency. So in this case, data inconsistency is the lack of data integrity. That means, as an example, again, in the customer file and the agent file, customer ID, then the customer name, then the phone number. Again, agent file, this customer's phone number available. So if you are going to change someone's telephone number, this is now 78, then you are going to change it as 077. But we forgot to make this change in this file. That means you forgot to update this file. At that time, you can see the same customer with two different phone numbers. As an example, let's take one person can have only, that means one person can have only one phone number as an example. So this is an example, not in a real case. So as an example, one person can have one phone number. So you are going to change this number as 077, but you forgot to change it in this place. So the same data, that means about same scenario, but different data available. So this is known as data inconsistency. Then data anomaly. In this case, there are three anomalies. The first one is modification anomaly. The second one is insertion anomaly. And the last one is deletion anomaly. Let's discuss these three with example. I'm not going to explain this example. Let's take another example. This one. First anomaly. This can be taken as, there are three anomalies. The first one is modification. Then the next one is insertion. Then the last one is deletion. Sure. Let's discuss about this one, modification first. We'll consider about modification anomaly. Let's take employee. And the project. This is about project. Yeah, this is about project. So project ID, then the employee name and or employee number, not name. Let's take it number as a number, then the designation and yeah, then the designation. So in P1 project, M1 employee, the designation is designer. Then P2 project, M2, you can take any as a clerk. Then P3 project, again M1 as a designer. There are some other records after that. Again P12, M1 as designer. So now we are going as an example. Let's take this M1 got the promotion as a tech lead. So the person who handled this file, as example, that means user as a end user only change this position as tech lead. So you can see when we consider about M1, he or she works for 1, 2, 3 project, but end user, that means user change only this position. At that time, you can see these two positions is with incorrect data. Okay, so we are going to modify the data as from designer to tech lead, but we only change one report. There are other 2 records to change. So this is known as modification anomaly. That means incorrect data may have to be changed, which could involve many records and having to be changed, leading the possibility of some changes being made incorrectly. Okay. අපි කරන්න යන්නේ මොඩිෆිකේෂන් එකක් කරන්න වෙනවා අපේ දීලා තියෙන ෆයිල් එකට. දැන් අපි මොඩිෆිකේෂන් එක කරන්න යන්නේ M1 කියන එම්ප්ලොයි එකේ ඩෙසිග්නේෂන් එක වෙනස් කරනවා ඩිසයිනර් ඉඳන් ටෙක් ලීඩ්. හැබැයි මෙන්න මේ ෆයිල් එකේ මෙයාට අදාළ රෙකෝඩ් තුනක් තියෙනවා. මේක මොඩිෆිකේෂන් එක කරන කෙනා කරන්නේ එක රෙකෝඩ් එකට විතරයි. එතකොට ඔයාලට පේනවා ටැන් දෙක එරර් ඩේටා තියෙනවා. එතකොට මේ වගේ අවස්ථාවකදී කියනවා modification anomaly එකක් තමයි ඇති වෙලා තියෙන්නේ. ඒ කියන්නේ වැරදි modification කරන්න යද්දී සිතමුණු වැරද්දක් තමයි තියෙන්නේ. හරිද? ඒක modification anomaly. Then let's discuss about insertion anomaly. In this case, it is the inability to add the data to the database due to the absence of other data. As an example, let's take this one. Wait. Okay. I'm going to take the insertion anomaly. In this case, as an example, let's take 2 tables. In this case, this is about customer. This is about yes. So the customer table customer file consists with customer name, customer ID, and the address. In this one, customer ID, then sales and the sales amount likewise. So in this case, you are going to customer C1, C2, Kamal, Chana, yeah, likewise take some values. Okay, so in this case, sale customer 1 sales is book amount is equal to 25. This is 35 to then let's take sales ID also. Sales 1 is 2, then about is 3. So now we are going to insert data about S3 sales, that means S3 transaction. So if you need to insert this data to this one, so it is needed to have a customer, that means have a customer ID. If you need to, so if you need to take the customer ID, this should be within this file. ඒ කියන්නේ දැන් අපි මේකේ දැන් 1 2 records දෙක පුරවලා තියෙන අපි 3 record එක පුරවන්න යන්නේ 3 record එක පුරවන්න නම් අපිට යාට අදාළ customer, ඒ කියන්නේ S3 පුරවන්න නම් යාට අදාළ customer ID එක පුරවන්න ඕනේ. හැබැයි මේ customer ID එක මෙතන තියෙනවා නම් විතර අපිට මේව පුරවන්න පුළුවන්. හදිස්සියවත් ඉඳලා මේ customer 4 වෙනියා. That means customer ID is equal to 4. So S3 is belongs to customer 4. So we don't have any records about customer 4 in this table. So we are unable to fill this file without having this 4. At that time, insertion anomaly occur. This insertion anomaly occur in this case. So as an example again, S3 is belongs to number 4 customer, but number 4 data about number 4 not available in this file. So now if you are going to fill this table, you cannot do it because C4 not available in this. That means customer 4 is not available in this table. This time, this insertion anomaly occur. Is it clear?
Yes.
No doubt. Is it clear, or do you want me to explain it again?
Can you explain it again, ma'am, please?
Okay. As an example, let's take.
Madam, there that if you are defining a primary key in the table or that database,
Oh yeah.
the database table, then that error won't occur, no? If you are giving us one key, the unique key when you are defining the table,
Yeah.
it won't occur, no? That
It won't occur. This one, yeah. That means insertion anomaly.
yes, madam.
So we are going to talk this. We are going to discuss these things in later part of this. I think you have. Yeah, you have some idea about primary key. In last week, I think it was this.
No, CSC session also we learned that.
Which one?
The initial part, that computer science introduction.
Introduction part. Introduction.
That's access database.
Yeah. That is ICT. Then you can see. I'm going to explain it again. Insertion anomaly. In this case, there are two files as customer and the sales. In this case, it is needed to have customer ID in this sales table, then the customer ID, sales ID. In this case, customer ID, then the customer name, and so on. So 1, 2, M. Mala, then Pereira. These are the two customers in this file. In this case, there are two sales S1, S2. This is belongs to second customer. This is belong to third customer. Now we are going to enter S3. That means third. S3 means third sale, about third sales. So in this case, this is belongs to customer number 4. Is it available in this table? Is it available in this table? Customer 4 is no. So at that time, this insertion anomaly occurs. So we cannot insert, or we are unable to insert S3 without inserting 4, that means customer 4 into this table. That is known as insertion anomaly. I think now it was clear. Then the last one is delete anomaly. In this case, it is unintended loss of data due to the deletion of other data. As an example, let's take the agent and salesperson and salesperson, then the product, then the product ID, then the product name, and the product amount. So S1 customer, books, quantity is 35. This is, amount is 155. So I'm going to, this is again sales file, in sales file, sales ID S1, then sales name Amal, then telephone number, like this. So as an example, let's take this sales, that means Kamal. Kamal is going to quit with this shop. That means Kamal going to quit with this shop. බඩු දෙන එක නැවතුවා. එහෙම වුණාම then the end user going to delete this one. He is already delete this. At that time, in the database, it should delete this also. At that time, you can see the inventory about this sale. That means this product is lost from the database. ඒ කියන්නේ අපි දැන් මෙයාව මේ කස්ටමර් අයින් වෙනවා. ඒතර එයාට කස්ටමර්ට අයිති සියලුම රෙකෝඩ්ස් ඩිලීට් වෙනවා. දැන් මෙයාව ඩිලීට් කරනවා. මෙයාව ඩිලීට් කරනවා. හැබැයි මෙයාව ඩිලීට් කරාට පස්සේ මෙන්න මේ බුක්ස් කියන රෙකෝඩ් එකත් කියන්නේ මෙයාගේ මේ රෙකෝඩ් එක අදාළ මේ බුක්ස් ගන්නත් යනවා. හැබැයි එයාලා අන්තිමට ඉන්වෙන්ටරි එක හදද්දි ඒ මාසෙට අදාළ මෙහෙන් ගත්ත බුක්ස් ටික අපිට නැති වෙනවා. අන්න ඒ වගේ එක ඩිලීෂන් එක නිසා unintended deletion එකක් නිසා data loss වෙන එකක් අපි deletion anomaly එකක් කියලා කියනවා. Okay. This is about history of the database. Then let's discuss about introduction to database management system. So you can see this is the file system. In this file system, in our previous example and the file system, you can see they keep different files for different scenarios. You can see separate files for each scenario. So HR department keep the file for employees, and the sales department keep the files for customer as well as sales, and the account department keep the file for accounts. So this is bit complex, and it is bit complex to find the relationship between each and every file as solution of this. Not only that, as a solution for inconsistency, anomalies, then the dependencies and other structural dependencies. This as solution for that issues, this database management system was invented. So you can see this is a database management system. This is the database. So this is the database system. All these three departments can access one file. Let's take this is a one file. In this case, they have separate file to access their data. But when we consider about database, all these three departments can access the same file. So this is the greater benefit in this database management system. And this DBMS is possible to eliminate the most of the file systems issues such as data inconsistency, then the data anomalies, then the data dependencies, and the structural dependency problem. Okay, so the current generation of DBMS software stored not only the data structure but also the relationship between the database components. Okay. So you can define the database, you can save the data, you can define the database, you can create the database, then you can store the information, you can sort the information, you can update them, you can manipulate, you can generate reports. All these facilities are available with database management system. Okay. So you can see. What is database system? The database system is organization of components that define and regulate the collection, storage, and the management and the use of data within the database environment. So the database system is the organization of components that define and regulate the collection, storage, and the management and the use of data with the database environment. So the database system is consists with hardware, software, people, procedure, and the data. You can see this is an example for database system. So this is the database environment. This is the database, DBMS, data, hardware, then the software, and also some users. So this is the database environment. So when we consider about this database system components or a major part, the first one is hardware. Hardware defines all the system's physical devices. In this case, it can be a microcomputer, it can be a mini computer or a mainframe computer, and also we can define keyboards, mouse, modems, printers under this hardware category. So if you want to create a database, you need to have at least one computer with this hardware. Then, when we consider about database to database, it is needed different kind of hardware components. Okay, when we consider about huge database system, it needs some servers. But when we consider about small, that means not complex one, small one, it is only need a desktop with internet connection. Okay, so likewise they are differ from various requirements. Then about software. Software refers to a collection of programs that used by the computer within the database system. So that means the collection of software which is used to create and to maintain this database within the database system is known as software. You can see these are some software available with the database system. The first one is operating system, then DBMS software, as well as application program and the utilities. When we consider about this operating system, I think you all have some experience with the operating system. What is operating system? What is operating system? What is meant by operating system? And give me some example for operating system.
Windows 8, 7, 9, 10, like that.
Only Windows. What are others? What are others? Mac.
Linux, Linux.
Yeah. Likewise, you can see some operating system. So the operating system is a software. So when we consider about this operating system, it is the it is a user interface between user and the computer resource. Operating system is a user interface between resources and the users. So these are some examples for operating system. This operating system has responsible for manage all the hardware components and make it possible for all other software to run on the computer. So this is about operating system. When we consider about DBMS softwares, this software manage the database within this database environment. So example, Microsoft Access, SQL Server, Oracle Corporation, that means Oracle, then MyBase. There are so many databases. In this module, we are going to talk about SQL Server. I think SQL Server, yes, practical classes are conducted by using SQL Server. So the DBMS software are the software you can use for managing the database within the database system. Then about application softwares and the utility softwares. So in this case, if you need to generate reports, then the tabulation and other information which is used for the decision making, you can use this application programs to, that means application program software to produce those things. And this utility software is the software tool that is used to manage the computer components. In this case, if you need to access the data and if you need to generate the reports, tabulation, and other information, you can use the application programs. If you need to manage the database component or the computer component, you can use this utilities softwares. Okay. Then about people. When we consider about people, these are the people's 5 types of users use this database: system administration, then the administrators, then the database administrators, database designer, then the system analyzer, and the end user like us. So the system administrator has responsible for the general operation within the database, such as he has responsible for security and the resources of the database. Then the database administrator, he is the person who manages the database use and ensure that the database work properly. And the database designer, the person who designed the architecture and the structure of the database. Then the last one, not last one, then the next one is system analyst and program. He is the person who analyzed the database. That means whether you can implement this one, what are the software and the hardware component necessary for to create this one. Likewise, system analyst and the programmer is the person who programmed the database. So these are the main function done by these two categories. Then the last one, end user like us, they are the person who use the database. As an example, supervisors, managers, directors, as well as sales clerk. Then about procedure, the procedures, when we consider about procedures, the instructions and the rules that govern the design and the use of the database system is known as procedures. Then about data, so when we consider about data, the data is a raw materials, and we can use this data to create the information. So the database system can be created and managed at different level at the complexity. So no need to go through these things. So data is raw material. So the data that covers the collection of facts that is stored in the database. So this is define the facts that needed to be stored in the database. So these are the main components: hardware component, which is used to create the database and the maintain the database software, and the people and the procedures, as well as data. Is it clear or any doubt? Are there any doubts? If you have doubt, you can Is then about types of database. So you can see with the requirement of the database, requirements of the database, the complexity and the structure of the database is different from one scenario to another scenario. In this case, it is a movie rental one. Two people can manage this movie rental system. One hardware is used hardware is used may probably in a single personal computer. Single personal computer procedure are also probably simple, and the data volume and the data volume also low. But when we consider about national insurance claim system, it is bit complex than this system. So it is needed to identify different types of, so it is needed to identify and examine different types of database. So in this session, we are going to talk about types of database system. So these are mostly based when this database systems, that means DBMS, can be clarified or classified according to the number of users and the database sites location, as well as expected type and the extent of users. So these are the three categories. Based on these three categories, we can divide this database into various types. Okay. I'm not going to explain all this. Okay, so database is great. Database system can be classified based on the number of users and the database site location, and the next one is expected type and the extent of use. In this case, number of users, and in the first one is number of users. Based on this one, we can divide database system into two parts as a single user and the multiple user. This is single user. So this is multiple user. By based on this number of users, we can divide database management, that means database system, into two categories: single use database system and the multi-user database system. In this case, single user database management system support only a single user at a time. In this case, single user at a time. As an example, let's take ABC. So this is the database. Now A use this database. That means A use this. Now A is using this database. So B and C must be wait until A user complete his database work. Then the next one is multi-user database. In this case, DBMS supports many users at a time. That means at same time. So the single user case, single user can support at a single time, but when we consider about multiple users can support at the same time. So this is based on number of users. Then the next one is database site location. So under this, we can categorize database into two parts as centralized one and the centralized DBMS and the distributed DBMS. So in this case, it supports database located at a single site. In this case, this is support for database stored in a single site. ඒ කියන්නේ එක site එකක තියෙන database එකකට විතරයි centralized DBMS වලදී support කරන්නේ. In distributed DBMS that support the database distributed across the several different sites. So in this case, it supports for DBMS in several sites. Okay. Is it clear? In the number of users, there are two categories as a single user and a multiple user. In a single user at the same time, it allows single user at the same time. In the multi-user case, it allows multiple user at the same time. Then we are going to discuss about database site location. In this case, we can divide the DBMS into two parts as centralized DBMS and the distributed DBMS. In centralized DBMS, it supports the database located at a single site. In distributed DBMS supports the database distributed across the several different sites. Okay, then the next one is expected type and extend user. This one. Yeah, this one, expected type and the extend user. Based on this, we can divide database system, that means into two categories as a transactional DBMS and the decision support DBMS. In the transactional DBMS, it is control the database which is designed to support the immediate response. So this transactional, that means this is suitable for the sales. That means transaction in a supermarket likewise. So it need to have an immediate response. That means this DBMS supports, this DBMS can control the database which is designed to support the immediate response. But when we consider about decision support, this is mostly focused on the produced information required to make decision. In this case, it provides the information about decision. In this case, it provides the information about immediate transaction. That means it responds or it support for immediate response. Okay, so these are the main types of database management systems. No need to put your student number, name, and the other thing. What is other thing? Center into chat. Okay, so this is about type of database. This is about again DBMS component, data standard operation, DDL, then the data manipulation and the query language, then the programming tool and the file structure. No need to discuss it again and again. Then let's move into before that. These are the components. No need to discuss about the components in DBMS. Then let's discuss about database model. So this is very important. When we consider about database model, it is a collection of logical constructs used to represent a data structure and the data relationship found within the database. This can be grouped into two categories as a conceptual model and the implementation model. In the conceptual model, it's focused only on the logical nature of the data representation. That means in this case, it is only concerned with what is represented in the database rather than how it is represented. So these are the example for in conceptual model. There are two models as a conceptual model and the implementational model. In conceptual model, it focuses only on the logical nature of the data representation. So you can see there are two ways to model this one. The first one is ER model. Then the next one is object-oriented model. Then about implementation model, next one. So in this case, it emphasizes how the data are represented in the database or how the data structures are implemented to represent what is model. So these are the example for implementation model: hierarchical database model, network database model, relational database model, and the object-oriented database model. So now we are going to talk about these things in detail. Yeah, I'm planning to cover the new session also. Okay. Okay, now we are going to talk about our first data model, that means hierarchical database model. This is available under the implementation model. So under the implementation model, we are going to discuss about our first model. It is hierarchical database model. So when we consider about this hierarchical model, you can see this is a picture of hierarchical model. In this case, you can see the data elements or entities are organized into a tree-like structure. You can see, can you all identify this structure? This is a tree-like structure, that is tree structure. So in this case, data are organized according to the association that are represented as a tree. So you can see it has a collection of record logically arranged to create a tree structure. So when we consider about this, so these are entity. That means, as an example, I'm going to take a scenario. Student follow degree. A student follows a degree. In this case, student and a degree is student and the degree are entities. Okay, we are going to talk about these entities in detail in upcoming lectures, so no need to worry about it. So when we consider about this one, we can call it as a entity. So as well as we can call it as a record. So this is an entity or a record. So you can see there are how many entities in this diagram, this tree diagram. How many records in this tree diagram?
6.
6. So there are 6 entities. Okay, you can see this. We can take this as a level 0. We can organize into a level. So this is level 1. So this is level 2. Okay, so when we consider about this one, that means top of the tree. So when we consider about top of the tree, we can call it as a root. So this is the root of this tree. So, or a root of this hierarchy. When we consider about this one and this level, so this is the top level and the top root is known, that means top entity is known as a root. So when we consider about this entities with respect to this one, these entities can be called as parent entity with comparing with lower level entities. When consider about the higher level entity, with comparing with the lower level entity, we can call these entities as parent. So අපිට උඩ level එකයි පල්ලෙහා level එකයි ගැන compare කරාම අපිට මේ උඩ level එකේ අයට parent ලා කියලා කියන්න පුළුවන් පල්ලෙහා level එකට සාපේක්ෂව. So you can see upper layer, that means upper layer is known as a parent of the segment which directly beneath it, and they are called the children of that parent. So when we consider about this entity, so this entity is a parent of this entity and this entity. So the permanent is a parent of software engineering and the manager. So this is the root entity. When we consider about one entity, the upper level entity for that level is known as a parent. So this is the parent entity. So this is a child entity. So these are parent, these are child. So when we consider about this hierarchical model, each parent can have many child, but one child can have only one parent. Okay. Each parent can have many children, but each child has only one parent. So when we consider about a parent can have many child, but when we consider about a child has only one parent. So this is the main relationship in this hierarchical model. The data are organized as a tree structure. The top entity or top record is known as root. All the other entity are combined with the parent and child relationship. When we consider about parent can have many child, but child has only one parent. So this is the main concept behind this hierarchical data model. So
Madam, then that root also we can consider as parent, no? When considered to the previous
we
parent.
consider about these three entities. Root is a parent of these three entities. That means to this employee, that means root entity has three child as a, that means not child, three children, permanent, contact, and the intern. Then you can see. Okay. As an example, let's take a software company. In this software company, they handle some project. Yeah, they handle some project. In a software company, they handle some project. So it is needed to keep the information about software projects as well as the programmers. In a software company, this company handles some projects. In this project, projects are done by the programmers. So it is needed to keep the information about project as well as the programmers in this database. Okay. So when we consider about this one, that means project, it is needed to keep the information about the name of the project and the date, start, and the estimated cost. But when we consider about the programmer, it is needed to have the information about name, then the pay rate, and the date joined to the company. So finally, it is necessary to hold the information of which programmer works on which project. So in this case, project and the programmers, project, then the programmer. So finally, it is needed to find the information about programmer works on which project. Okay, at that time we can have, that means one possible way to depict this scenario by using a hierarchical model is like this. So you can see the first top, that means root is the project, then the programmer together. Yeah, like this. when we consider about this one, this is the information. So it is needed to find the programmer work on which project. So it is needed to find the P1 programmer, which are the, that means what are the projects allocated for P1 programmer. So you can take project as a root and you can take the programmer. This is one possible way. And also you can build a hierarchy more like this: programmer, then project, like this. So no need, can make a issue. There are no any issues. You can use one possible way to model the hierarchical diagram. Okay. So this is about entity of this is the project and the progress. These are the records of entities. So as an example, according to our example, they need to keep the information about name of the project and the date, start, and the cost. So it is needed to have the information about date, then the cost and the project. And this case, name and the programmer ID, project allocate, and the so on. So we can denote the attributes as in hierarchical model like this. You can see this is the first way. There are two ways: the programmer as a root or project as a root. So let's take this one, project as a root. So when we consider about project as a root, sorry, you can take the attributes like this. So this is about project. These are the attributes of the project ID, then the project name, then the project date, start date, then the estimate costs. All these are belongs to project entity. So you can represent it like this. So the top element is project, then about programmer. Then you can take the programmer attributes into next level. In first level, you can take the project attributes. In the second level, you can take the programmer attributes. Likewise, you can denote both entities and the attributes by using a hierarchical model. So in this case, you can see when in this, now it shows some values. That means, it shows some value. In this case, attribute, in this case, entities. That now it's about values or records. So now we are going to discuss how we can indicate values or the records into hierarchical models. So in this case about project, so you can take the record of project. So the project 2 inventory source, then these are the this is the start date, this is the cost. Then about programmer, then you can see when we consider about project 2, how many in this case there are in programmer. Let's take programmer 1, programmer 2, programmer 3. How many programmers in this project 2?
3.
3. So it is needed to indicate all 3 programmers in this level. Keep in mind when you are inserting or when you are representing records by using a hierarchical model, if this project has a 3, as example, if this project has a 3 programmers, so it is needed to indicate all these 3 and in this level. So according to this example, that means in example in the slide, it has 2 programmers. So the programmer 3 and the programmer 2, it's already depict the 2 programmers in this level. Is it clear?
Yes.
Okay. So this is the main thing. With all others are characteristics. So you can go through these characteristics and the advantages. So this is the theory part. No need to repeat it again. The basic thing is in hierarchical model, data are organized as a tree structure, and the top entity is known as entity, or a record is known as a root. Other level consists with parent and the child. The top element, that means element in the top layer, higher layer, is known as a parent. Element in the lower layer is known as a child when comparing two layers. So in this model, one parent can have many children, but when we consider about one child, it has only one parent. Then you can represent entities by using hierarchical model like this, and also you can represent attributes by using hierarchical model like this, and also you can insert some records into a hierarchical model. This is the structure. So these are the main things about hierarchical model. Is it clear? I think it was clear. Then let's move into network data model. So when we consider about this network data model, it is similar to a hierarchical model, but there are some differences. So the network model are based on the graph structure. You can see this is a graph structure. This network models are based on the graph structure, and this can be considered as the expansion of the hierarchical data model. So in hierarchical model, root, then the parent entity and the child. So in this case, in this network model, it is just like expansion of this hierarchical model, but there are some differences. You can see it also based on a graph structure. So the main differences between these two is a child record has exactly one parent in hierarchical model, but child record can have any number of parents in network model. So in hierarchical model, child record can have one parent, but in network model, child can have many parents. So you can see, identify the parents and the child. What are the entities belongs to parent? What are the parent entities in this structure?
Project 1.
Project 1 and
Program
project
1 and
2.
2.
Okay, then what are the child? Who are the childs in this structure?
Program 1, 2 and 3.
Okay. So when we consider about program 2, how many parents?
2.
2.
2.
Okay.
One and the project 2. Okay, this is the main difference between network model and the hierarchical model. In hierarchical model, one child has one parent, but when we consider about this model, child can have many parents. So this is the structure. The network database consists of two structures, out of which any database could be constructed. So any database can be constructed by using these two structures. The first one is set of records and the set of links. So these are known as records. That means entity are known as record. The link between these two entities are known as set of links. So in this case, this is a parent record. This is the child record. So this can be definitely, this is one to many. That means one child can, that means one to many. One child can have many parents. So this relationship is one to many. This relationship indicated by using this line. Okay. Project student, sorry, programmer. So one to many. This can have another parent like this. So this relationship is one to many relationship. Okay. This is the project, this is the programmer, this is the project programmer. So these are three entities. So you can see one project. This is one-to-many relationship. This is one-to-many relationship. So this is the parent, this is the child. Okay. Okay. The relationship between a parent record and a child record is many to many. When this is one to many, when consider about child to parent. Okay. So when we consider about total scenario, that means total entity, that means both entity, parent and the child entity, this relationship is many to many. I'm going to explain it. Okay. As an example, let's take this one, program project, and the project one, programmer one. No, I'm going to take this one. In this case, you can see when consider about this one, this is this project one done by programmer one, and the programmer two works for project one. So when we consider about one project, there are two programmers. So one, many. When we consider about this one, it has, that means this programmer one work for project one and project two. That means one to many. So this relationship is many to many. This is the cardinality. We are going to talk about this in the session number 11 or 11. So you can see one project can have many programmers. So when we consider about one programmer can work for many projects. So the relationship is many to many. Is it clear or not?
Clear.
Yeah.
Okay, then about this one. Yeah. Wait. So there are some network database terminology. When we consider about network database, so there are some terminologies associated with this network database. The first one is a relationship. You can see there are two entities and the relationship. This relationship is known as a set. This is known as a set. These are known as owners and the members. So owners are similar to the parent and the members are similar to the children. So when we consider about this one, when we consider about this one, again, I'm going to add some things like this. At the time, I think it was clear now than before. So in this case, when we consider about this one, this is the parent, this is the parent. So this course have two parents as lecturer and the student. So when we consider about this one, this relationship is known as a set, and this is known, that means parent record or entity is known as the owner, and child one is known as member. Okay. Owner is similar to the parent in hierarchical model, and the member is similar to the children in the hierarchical model. So you can see a set has one-to-many relationship between owner and the member in the figure. In this figure, one-to-many relationship. These are some characteristics, no need to explain it again. Then let's move into our next one. It is about relational entity and the object-oriented data model. The relational database. So when we consider about relational, before this is some, okay, before starting this one, do you need a break?
Yes.
Okay, then let's take 15-minute break. After that, we are going to discuss about relational database model and the entity relationship database model and the object-oriented database model. After that, we are going to discuss about our new session. It is about entity relational model. Then let's take a fifth. Yeah. Now it's 3:22. Let's meet again at 3:35. 5, 8, 13 minutes. Yeah. Let's take 15 minutes break.